My friends, welcome back to the weekend special we started yesterday. And today I want to work on the phase 2 of this model. The Model Mania 2009 is part of the SolidWorks program, and it is their property. On the phase 2 of 2009 challenge, it says restrain this face and then apply a load of 1000 Newton to this face. So it would be on the face, not on the top surface. And then it would be downward load. And then we do an FEM analysis, and it says determine the factor of safety and maximum deflection of the part. So we'll need a material type. Oh, it says material aluminum 6061. We will see if we have this material already in the FreeCAD library. Let's go ahead and start our FEM workbench. It comes with FreeCAD, this workbench. So this is the final object that we want to use. And on the FEM, there are like some step-by-step guideline, and without any description, I'm just gonna follow that steps. So first, bring an analysis container and put in a solver in that container, and then specify the material. And I think it says aluminum 6061T6, so that's the one. Good, we have it. And I want to see if it has Young's modulus, Poisson's ratio, but it does not have the maximum allowable stress in this material. So we may have to do a quick Google search, because we'll have to find out the factor of safety. Anyway, Google is there to help us. Right, we need to fix this. Okay, on this one though, I want to actually go ahead and hide these threads. I don't know if it's a good idea to leave them on during our FEM analysis. And I'm not sure actually these fillets are helping in our FEM analysis. We'll see. So this is where we constrained this face. So it's fixed support right there, right? And then we come to apply load on here. So it is the load button is here, constraint force. And on this, see, the direction says it's sideways, but we may have to make it downward. So let's go ahead, select this. Okay, take the add option by clicking on the add. Now it's not adding anything else. We just like select this line and say direction. And then that's taking upward. So, and then we say reverse direction, that's taking downward. That's what we want. And on the magnitude, we want to say 1000 Newton and hit OK. So we got the solver and the material and support and load. All we need is the mesh, and we select this face and come here and say end mesh. So as I discussed in the previous videos, especially the last one, the lower the mesh size is better for the analysis. Well, not so better for the computer, but we'll give it a try. It will take a minute. It did not work. How about Gmesh? I want to come here and say maximum element size is 10 and hit apply. Okay, so it says, oh, that's a lot of error. Okay, let's give it another try. Hide this and select the object and come to Gmesh. And on the element order, let's try it like first and make it auto and hit apply. Okay, and then come to solve it and run Calculix. Whoa, it worked. It did work finally. Okay, so I want to see, our target is to find the factor of safety and maximum deflection of that part. So when it says factor of safety, I'm guessing it's factor of safety against bending. Flexural stress factor of safety. I'm not thinking about shear stress on this one. And then that's all. So let's go hide this mesh and hide these results and come to double click on the CCX. Right here, we have the displacement magnitude, and it gives right away, we have 0.24 millimeter maximum deflection, and that maximum deflection is at the farthest corner of the object. Given it's a cantilever setup, that makes sense. We can actually see how it looks. So this is how the object will be bending under load, 1000 Newton of the load. And the maximum deflection here, it will be 0.24 millimeter. Let's talk about the stress. So we have 49 megapascal of stress, and that stress actually is coming at the top of the spine, which makes sense. Now, the bottom side, it doesn't show much of stress, anything at all, just a little bit compression. And that makes sense because the cross section at the bottom here is wider than the cross section at the top, which is like really narrow. So given the materials like aluminum, steel, this kind of thing are normally better in tension and a little weaker on the compression, so this design makes sense. But having only a thinner part of to handle all the stress, the tensile stress, it's actually really red and showing up on top of here. So maximum stress is 49 MPa, but we don't know what is the maximum allowable stress in this material, aluminum. So let's go find it out in Google. The maximum allowable stress, ultimate tensile strength, is 310 MPa, but we are looking for the yield tensile strength, which is 276 MPa. Okay, how about the specific material code? So we have aluminum 6061 T6. So on this one, the maximum allowable stress of aluminum 6061 T6 is approximately 241 MPa, which is different from normal, which is 276. So this is the value that we are going for, 241 MPa. That's our maximum allowable stress. And we have 49 MPa developed, 4.9. So that's our factor of safety for this design and this load. 4.91 factor of safety against flexural stress or rupture, and the displacement magnitude is 0.24 millimeter. Well, that's it, folks. Hopefully you like this video and the analysis, and of course the interpretation of the results in this FEM analysis. Thank you for watching. If you have any question or comment, leave them below in the comment section. I will see you in the next video.